All right, my name is Major Derek Worth, and I'm going to give you a brief overview and demonstration of motion capture image reprojection. This is a technique that I've created that allows us to take known three-dimensional points and project them into two-dimensional images, and is specifically useful in generating training labels for the supervised machine learning task of object detection. Now, this process involves capturing images of tags that the three-dimensional locations using a motion capture system. With the 2D and 3D point correspondence, the solved perspective endpoint returns the rotation and translation of those tags relative to the camera, and ultimately that allows us to not only reproject those same points or those same tags back into the image with very minimal residual pixel error, but it also allows us to take any three-dimensional point within this motion capture space and reproject it back into the image. All right, so what I have here are 900 images, actually 901 images, that I have captured within the motion capture space. The images also contain April tags that have these reflective balls that can be localized using the motion capture system. So the motion capture system reports the three-dimensional locations of these tags, and the April tag software reports the two-dimensional points of these tags in this image. And so with that, we can then use the perspective endpoint algorithm to back out the pose or the relative position of this camera relative to the tags, and that allows us to then ultimately reproject information or three-dimensional points within this space back into the image plane. So I'm going to incrementally start enabling things over here that depicts what's happening under the hood. So again, the motion capture system reports the three-dimensional locations of the tags. So that's the red dots that you see here. And the April tag software then reports on the April tags, and that's what you see in the top left here. So the green crosshairs are what the April tag software has reported as the center of the two-dimensional location of those tags. And that allows us to do the localization of this camera, which you see the virtual output of the camera in the top right. And then we can take from the perspective endpoint rotation and translations, we can then project those same three-dimensional points, those April tags, back into the image. And what you're seeing from that is these red crosshairs. So if I zoom in, if I make this a little bit larger, you can see that they don't align perfectly, but for the most part, they reproject within a minimal margin of pixel resolution or residual pixel error. So that gives us confidence that yes, these three-dimensional points are being reprojected back into this image, and our pipeline works. Now the significance again is being able to now that we've localized where the camera is, and we can reproject these points accurately back into this image. Let's do it with known three-dimensional features. So we've got these points defined in the motion capture space, these three-dimensional points, and we can essentially take those points and reproject them back into the image, and that's what this looks like. So I have now successfully completed the pipeline and reprojected points. Now what can we do with those points? So if I look at each individual point grouping, I have defined them as features. So this feature has 4 points with a 5th point representing its geometric center. And so like if I cycle through all these points, and you can see the points in the virtual world as well, these features made of multiple 3-dimensional points projected into the image represent features that we're going to draw bounding boxes around, and that's ultimately what we're going to train the neural network to find. So essentially what we do is we take these features and we surround them in the image, so they're showing up on these pixel coordinates, and then we draw a tight-fitting bounding box with a bounding box correction, and that gives us these truth labels. Now these truth labels are the labels that we're going to actually pass to our machine learning algorithm, and as you can see as I run through all the different images, these are being generated on the fly. So I haven't pre-computed or compiled anything here. I'm just, every time I move this this current image slider, it's actually reading the image from file, running the motion capture image reprojection pipeline, projecting the points, then drawing the bounding boxes all in real time. So the pipeline is very fast, and that allows us to generate very accurate training labels that we can train our neural networks with. And for this last part of the demo, I will show, let me unhighlight that. What I'm going to do is I'm going to, I'll keep these are the training labels that I trained the neural network with, and then I will actually enable the neural network. So now I've turned the neural network on, and let me back this out a little bit. So yellow is what the truth labels are. If I enable the blue is what the neural network is detecting. So I've trained it to find these boxes. The neural network is actually finding these boxes, and when we run it through our dual object detection pipeline, what you see in this bar graph is the residual error, and you'll see the drogue kind of jumping around. And this yellow line right here represents the probed drogue vector that our dual object detection pipeline outputs. And then you can see that also on the projected image here. So I'll go ahead and auto advance. So as we're moving the camera around, and if I turn off the truth labels, again, the blue is what the neural network is able to find, and then we're able to then use those 2D points and 3D points in order to back out a relative pose between the objects in the image, allowing us to create that probed drogue vector.